Hi guys, so today we're going to do our first lesson of 10.4. We're continuing in chapter 10 with quadratics. We're going to use square roots to solve quadratic equations. You've drawn them, you found the vertex, you've factored them to find solutions, and sometimes different quadratics have different ways to be solved. So here's another way to solve a quadratic. So here we go. Example 1, 2x squared equals 8. So you can see that we have A actually and C, and we're missing B. So when you're missing B, a lot of times you can use the square root property to solve it. So we are going to divide by 2 because we need x by itself. So this is going to cancel. It's really going to just become 1. But we don't need to write 1x squared. It's understood here to be a 1. So x squared equals 4. So remember that in the lesson I always told you the exponent tells you how many solutions. So I know that I should have 2 solutions here. So this is x squared. So just like addition and subtraction undo each other, we need to get rid of something squared. So the way that we do that is to take the square root. So we take the square root, and it's understood, we never write, but there's understood to be a 2 in the square root. That's why it's called square root. And in algebra, everything's balanced, so we take the square root of 4, and we always add a plus and minus, okay, because you need 2 solutions, and having one being a plus and one being a minus is going to ensure that you get 2 solutions. So now the next step is that we're going to have x equals plus or minus, and the square root of 4, it is a perfect square, is 2. So you can leave your answer like this, meaning plus 2 and minus 2. Or you can write it out, x equals 2 and x equals minus 2. Either one is acceptable, however you want to do it. You'll see it both ways in the books a lot of times. As you get more advanced, you'll see it more like this. Okay, so let's try another one. By the way, hopefully you like my little black glove. I thought it was kind of cute, so I wanted to put that on. M squared minus 18 equals negative 18. Okay, so again, we have A, because we're looking at the quadratic, ax squared plus bx plus c. So we've got the c part, and we've got the a part, which is 1, but we have no b. So that's how you know to use the square root property. So I'm going to add 18 and add 18. So now I've got m squared equals negative 18 plus 18 is 0. And 0 is a special number, because with 0 we don't say plus or minus. So in this case, instead of having 2 solutions, we are only going to have 1 solution. So we take the square root, and the square root of 0 is just 0. So here's that special case where we end up with 1 solution. Also, number 3. At this level, I want to show you an example of something that would not be a real solution. So say I have b squared plus 12 equals 5. So I'm going to subtract 12 and subtract 12. So then I have b squared equals 5 minus 12, which is negative 7. So if I take the square root of negative 7, I can't right now. As you get more advanced in Algebra 2, they're called imaginary numbers and you can solve them, but at this level, it has no real solution. So you're going to say no solution, because you cannot take the square root of a negative number. If I did this, I would not be able to solve that. So you put no solution if you see that. Okay, next example, example 4. We have 4z squared equals 9. Okay, so we are going to end up with a fraction, it looks like, because when I divide by 4, I end up with z squared equals 9 divided by 4. So you always look and see if you can simplify. 9 and 4 cannot be simplified. So your favorite thing is a fraction. So here we have one right now. So we still have to solve it, and there should still be 2 solutions. Okay? The only time you don't get 2 solutions is if you have 0, or right now if you have a negative number under a square root, you have no solution. So I'm going to take the square root and the square root and add a plus and minus, because that ensures me that I'm going to get 2 solutions. So again, the next step is that this will just be left with a z, because I have that imaginary 2 here and they cancel each other out. So I'm left with z equals plus or minus, and you can look at this as the square root of 9 divided by the square root of 4. So they gave us a nice one because these are still 2 perfect squares. Plus or minus, the square root of 9 is 3 on top, and the square root of 4 is 2. So z equals plus or minus 3 over 2. That is perfectly acceptable like that, or you can write them out separately. You can say z equals 3 over 2, or z equals negative 3 over 2, and those are your 2 solutions. Okay, so the next example, example 5, they just add a little bit more to it. 3z squared minus 11 equals 7. Okay, so now our goal is to get z by itself. So obviously, the last thing we do is work with this. We have a minus 11, so we're going to add 11 to both sides. That's how you undo subtraction by addition. So this becomes a 0. So it becomes 3z squared equals 7 plus 11 is 18. Okay, so now we have to get rid of the 3. So we're going to divide. Divide both sides by 3. That just leaves us with 1z squared, and we don't need to write the 1. And 18 divided by 3 gives me 6. So I can look already, I know 6 is not a perfect square, but it doesn't mean that there won't be 2 solutions, because you can have an irrational number, which I'm going to show you it's going to become. So I'm going to take the square root of z and the square root, and remember, always add that plus or minus. If you don't, you will not get the 2 solutions. So then it becomes z equals plus or minus the square root of 6, which is fine, or you can write it z equals the square root of 6 and z equals negative square root of 6. And that is perfectly fine. If you want to find the decimal approximation, that is fine too. You can see z equals plus or minus. It's approximately 2.45. But I'm not going to require you, but just in case you have a quiz or some kind of multiple choice and they give it to you as a decimal, you just put it in your calculator and you get an approximately 2.45. But keeping it as a irrational number right here, this is absolutely fine too. Okay, so now we're going to move on to the last couple of examples. Example 6. So they just add a little bit to everything. You start out very simple and you just keep making the equation larger. Okay? So here we go. We have 6 and then parentheses x minus 4 to the second power equals 42. Now don't ever try to multiply 6 times x and 6 times negative 4. And the reason you're not going to do that is because you're raising this to the second power. If it did not have that and it looked like this, then go ahead, you can multiply. But you can't when there's a power other than 1 there. So you have to divide then. So I got to get rid of the 6. So I divide the 6 into the 24. So this again just becomes 1. So x minus 4 raised to the second power equals 7, because 42 divided by 6 is 7. So now this has a term. X minus 4 is a term, and it's squared. So I just take the square root. I take the square root of 7, add a plus or minus. Okay, so when I take the square root of something squared, whatever is inside just comes out. So the whole term x minus 4 comes out equals plus or minus square root of 7. So we just have an extra step to do here. We have to add 4 to get x by itself. So I'm going to add 4, and the 4 goes before the plus and minus. So watch how I write this. X equals 4 plus or minus the square root of 7. And that is absolutely fine. There's 2 solutions. Or you can write them out. X equals 4 plus square root of 7, and x equals 4 minus square root of 7. You'll see it both ways in books. They mean the same thing. So if you see them written in different ways for homework or on a quiz, you know they mean exactly the same thing. All right, let's try one. I'm just going to make one up with a fraction. So say I had something like this. 2/3 x minus 6 squared equals 6. Okay, I'm completely making this up. So we have a fraction here. So how do I get rid of this fraction? So I have 2/3. So remember that little rule where we took the reciprocal? So I need to get rid of 2/3, and the reciprocal is 3/2. So I multiply by 3/2, but then I have to multiply, this is multiplication, 3/2, not a decimal. That's why I make it darker. So now you know that 3 divided by 3 and 2 divided by 2, these are all going to simplify just down to 1. So you're going to be left with x minus 6 raised to the second power equals, put this over 1, if that makes you feel better. Always look and see if you can reduce top to bottom. 2 divides into 6 3 times, correct? 3 times 3 is 9. So now I have x minus 6 raised to the second power equals 9. Then I'm going to take the square root and the square root, and also straight away do that plus and minus. Otherwise you might forget. So now I've got the term x minus 6 equals plus or minus the square root of 9. Okay, so the nice thing is that this is a perfect square. So it worked out really good. So if you have these kind of problems in homework, you know how to solve them. So the next thing is x minus 6 equals plus or minus. That is a perfect square, so I'm going to go ahead and take that out. So I've got the plus and minus 3. Now I need to add the 6, and I add the 6 before the plus and minus. So x equals 6 plus or minus 3. Sorry, here you go. So x equals 6 plus or minus 3. Now you don't want to leave it like this because they're 2 answers. They're not irrational numbers where you had 4 minus the square root of 7. You just left it like that. These are proper numbers that are not irrational. Not that an irrational number isn't proper, but it can be simplified. So one of the answers is 6 plus 3, which is 9. And the other answer is 6 minus 3, which is 3. So here is your final solutions, 9 and 3. So hopefully this will clear up 10.4. So go ahead and work on homework, and don't forget to turn in by Office Lens, or if you download the TMAPS onto your phone, you can also turn it in immediately that way. It's a lot easier. So it's up to you how you do it. Okay, guys. God bless. Take care.